Hello everyone, back into the 12th and final Winter 2017-18 update from GWV.com. So, we've done 11 updates so far. We started them on the first weekend of September, the first Sunday of September. Every Sunday we've done a winter update since then, combined with 3 seasonal model roundups. We did the last third and final season model roundup yesterday on Saturday. And that was quite an interesting one because, again, most of the long-range models are going for a very wet winter, and also, generally, most of them are mild. There were 1 or 2 that were nearer average. Just one of them, that was colder than average, that's Beijing Climate Centre, but most of them were painting a mild and wet picture for the winter to come, winter 17-18. And this will be placed within the winter forecast that we can do in just 1 week's time. Now, so I've got one more winter update to do. For the final time, I'm going to talk you through sea surface temperature anomalies, what's happening with ENSO, solar activity. We'll have another quick look at Siberian snow cover, and we're going to try and have a look at some analogues for November, although this November has been causing a lot of uncertainty. It's been causing a lot of sleepless nights for myself and analogues guru James Ackland. I'll talk you through that in a second. But as I say, this is the final time we're doing a winter update, and then once this one is done and dusted, we will combine the winter updates with the seasonal models, and on Sunday the 3rd of December, just 1 week's time, we're going to release the GWV.com Winter 2017-18 forecast. So it could be a very, very significant moment, this, the final winter update. Just say that later on today, we've got the Winter 17-18 forecast from our long-range guru, Terry Scully. So what I'm doing really is just having a bit of fun with these updates. But Terry really is the long-range expert. He's been at it for like 40, 50 years, so he knows his stuff. And this afternoon, around 2 o'clock on Terry's page, I'll issue on Terry's behalf his Winter 2017-18 forecast. I've had a look at it, and I tell you that it is a tremendous work of sort of art beyond being a very interesting forecast. The depth to which Terry goes into within his winter forecast is quite extraordinary, actually. So do have a look at that, 2 o'clock this afternoon. You'll see how a proper long-range forecaster brings their forecast together. And then this evening around 7 o'clock, we'll have a bit of fun with another Christmas update. I think we're up to around the 12th, one of those, so we're nearly halfway through with the Christmas updates. But it's all beginning with this 12th and final winter update. Just say it could be quite a long video, so you can't watch it all in one go. Don't worry, it will be kept on the website indefinitely. You watch it right now on the homepage, but later on today, this video is going to be placed within the winter updates page of GWV.com, and we'll have an extensive written report that goes with it as well. So you can come back and watch the video whenever you want, and you'll also be able to have a read of that written post as well if you can't watch the video all in one go. And I think that's just about it for the announcement. So just to say, I suppose, that the Christmas shop is open. So if you've got any Christmas shopping to do at Amazon between now and Christmas, please click the green button that says Gav's Christmas Shop. It takes you to our Christmas shop page, and then from there you'll know you're on the right page because you'll see the snowflakes fluttering down the screen. From there, you just click through the Amazon banners. You go through to Amazon, do Christmas shopping as normal because you've gone from GWV to Amazon. We go around see on the things that you are buying, and a big thank you to everybody for doing that. And without further ado, I think we better get on with the 12th and final Winter 2017-18 update. So for the final time this season, we're going to begin by having a look at the oceans. All the way through winter updates, we've been looking at both the Atlantic and the Pacific Ocean. So that, of course, being the Pacific Ocean, that is the large expanse of water. That is the Atlantic Ocean. These are sea surface temperature anomalies from NOAA. There's 3 specific areas we've been interested in. We've got the ENSO region just there from Peru to Indonesia across the equatorial Pacific Ocean. Then the northern Pacific Ocean, we've been interested in that. I mean, of course, the northern Atlantic Ocean. And juxtaposed to that, we've also been looking this season at the very warm sea surface temperature anomalies that we've had in the Norwegian Sea. We had a little bit of fun with that because earlier in the update I was wrongly naming that the Barents Sea. So that was a little bit embarrassing for myself. But so this is the sea surface temperature anomaly map that we had last week when we did the 11th update. So feast your eyes, that's how things were looking 1 week ago from the 16th of November. Let's go through to the very latest, and this is it. So in 1 week, this is how the oceans have changed. Let's deal with the Pacific first of all. So that was the position in terms of the equatorial Pacific Ocean and La Nina, the cold event signature this time last week. Let's have a look at the latest right now, and I think we have seen further strengthening of the La Nina signal through the equatorial Pacific over the past week, particularly in this area just here, but I think all areas have cooled again, so this is still looking like at the very least a weak La Nina, possibly even a moderate La Nina, because it's so late in the season. And this is the uncertainty with the long range models, because the long range models around 3 or 4 months ago, they were all forecasting El Nino. And what's happened is that very late in the day, around August, September, we saw a switch to La Nina, to a cold event, very unexpected by the seasonal models. So that's why all of the long-range model output has a question mark over it, because it's they are playing catch-up to try and work out what this unexpected, for them, cold event means. But we have seen, again, further strengthening of the La Nina signal over the past week, so we do now have proper La Nina condition, most definitely, and it is at the very least a weak La Nina. I reckon that's probably reaching moderate La Nina type territory now. So weak to moderate La Nina condition in the ENSO region, with further strengthening over the past week. You notice as well in the past week, the blue colours to the south of the equatorial Pacific have become more extensive around this area, and that can sometimes be a precursor to continuing La Nina condition. I think we've also cooled the coast off the Chilean coast, so this water just here has probably cooled a little bit over the past week, or certainly become more widely cold. So this is looking not only like it's going to be a La Nina that we've got a La Nina now, it is looking like that most definitely. It's also looking like an event that could continue for quite some time. There's no sign of these cold sea surface temperature anomalies down here in this area just here sort of running out of steam at the moment. So this could go on for some time, actually. It may last for a while into the early part of next year. What about in the northern Pacific Ocean? Well, that situation last week in the North Pacific, this situation now, very little change, but I think we possibly have cooled things down a bit more in this northeastern part of the Pacific Ocean. With this part looking so cold now in terms of the temperature anomaly, sea surface temperature anomaly, you would expect before long that we'll start seeing an effect beginning to appear in the northern Pacific, because typically when you've got La Nina going on, it doesn't just affect the equatorial Pacific and the southern Pacific Ocean, the South Pacific. It tends to also have a cooling effect on the North Pacific. So as we go through the next few months, I wouldn't be surprised if we don't see the PDO shifting deeper into a cold PDO type setup. That's the Pacific Decadal oscillation. So I reckon the next few months we'll probably see the northern Pacific Ocean cooling down as well. For us in the UK and Europe, we want this to be as cold as we can get it, really, I think, because that tends to be a signal. When it's warmer than average there, you tend to have a ridge somewhere around here, and you'll tend to have the jet stream going like that across the states. Of course, that pulls down very cold air from Canada, that cold air can then blow up on the east side of America and enhance the jet stream, bring in tremendous cyclogenesis, and then you'll get low pressure coming across the Atlantic into Europe. So we want to see, for a cold winter, assuming that quite a lot of people are watching this, they want a cold winter, we want to see that area getting increasingly cold. It is cooling down a little bit, but it is still quite warm. It's not as cold by any means as it can get up there. Further over into the Atlantic Ocean. So again, this situation in the Atlantic Ocean last week. This is the situation now. Very, very little change. Things are very stable at the moment in the North Atlantic Ocean. We might have cooled the sea surface temperature anomalies down a little bit to the south of Greenland. Otherwise, many other parts of the Atlantic still looking quite warm. We have got quite a warm North Atlantic Ocean this year. There's been no real change in terms of the warm temperature anomalies in the Norwegian Sea. Those have cooled down quite a bit from October, but they are still significantly warmer than average, those sea surface temperature anomalies up there. I've been asked by somebody about this area just here. This red area that you'll notice running up the eastern side, eastern seaboard of America. That is primarily the Gulf Stream in action, but we do see that we have got some very extensive warmer than average sea surface temperature anomalies there developing around that eastern side of America. Not sure what the impacts of that are. I'm not sure there really are all that many impacts, but what that could do as we go deeper into winter, if these warm anomalies push northwards, they might start to warm this area a little bit. And to the south of Greenland is one of the areas that we look at to see warmer than average sea surface temperature anomalies, because what we want to see for a negative NAO, or for an increased chance of a negative NAO, is a tripod. So we want it to be warm there, want it to be cool there, and then we want it to be warm again, 3 distinct bands. So if this warm area off the eastern side of America was to push northwards, it might be that it would warm all of this area just here. The person that asked me about this was a bit worried that as the cold air pulls out of America, if it does pull out of America, it might hit these warm sea surface temperature anomalies with the cold air running over top. That could be an explosive sort of breeding ground for cyclogenesis. And of course, that is always an inherent risk, and those warm and average sea surface temperature anomalies that we have there off the eastern coast of America up to Newfoundland, they could do that, but it will depend very much on what the pattern is over America, because it's by no means guaranteed that we will see the jet stream doing that. Actually, when you have a La Nina, when we have that sort of signature in the Pacific, you tend to get quite mild winter, so you'll tend to just get the jet stream going northwards over the top of the states, rather like that. It does tend to bring a lot of cold weather to Canada, but for America, actually, you'll tend to get quite a mild ridge developing in the south, in the southern part of the states, and that pushes the jet stream northward. So it's by no means guaranteed that we will get this northwest-southeast trajectory to the jet stream. But if we did do that, I suppose these warm and average sea surface temperature anomalies, these SSTs that we have there off the east coast of America, they might do something in terms of explosive cyclogenesis. I thought I'd just show you for one last time the sea surface temperature anomaly maps from NOAA for around this time of year, going back into previous years. So this is how things were looking. We're going to focus primarily on the Atlantic. This is how things were looking in the Atlantic this time last year. You'll see that the red area, that warm area, was actually more extensive at this point last year. Also, we did again have quite a warm Norwegian Sea. So in many ways, the sea surface temperature anomalies that we have in the Atlantic at the moment are quite similar to what we had last year, but a little bit more toned down. And what we said last year is that whilst the Atlantic wasn't particularly set up for a negative NAO, it was more conducive to potentially bringing about a colder winter. And that did come through, because it was a very cold winter in the east of Europe and the southeast of Europe, less so for the west and the northwest of Europe, and that's because of what the Atlantic was doing. And we are in a kind of a similar state to that for this year. So the Atlantic will be an important factor when we come to do the winter forecast next week. I'll talk you through some other years. So this is how things are looking at this point in 2015. Notice in 2015, actually quite cold around this area. Generally fairly cold in the northern Atlantic, milder in the southern more tropical part of the Atlantic. That's very much a positive NAO type signature that we have there. And of course, we did have a positive NAO, very much so, winter of 2015-2016. This is this point in 2014. So again, you see, we do have this area around the eastern coast of America. It's not all that unusual to see, but it is partly, at least for Gulf Stream, moving up out of the Gulf, up the eastern coast of America. So it's not all that unusual to have those red areas. A little bit more toned down compared to this year. This is 2013. This is how the Atlantic was looking just as we was about to go into that horrendous, horrible winter of 2013-2014 with all of that torrential rain. You'll see that at this point, generally quite a warmish Atlantic, but a little bit cooler actually around here. This is 2012. Interestingly, just as we was about to go into our last cold winter, we did have this warmer than average area sea surface temperature anomalies at the eastern side of America. But notice in this instance, they are beginning to push up towards towards Greenland. So we almost are setting up a tripole at this point at the end of November. In 2012, we've got that warm area just there, we've got the colder area just there, and then we're warm down here. So it wasn't really expected, but through the autumn of 2012, we did start to set up a little bit of a tripole, and that became more and more evident as we went through the winter. That's a reason that as we went further on, or one of the reasons anyway, but as we went further on, winter of 2012, 2013 got cold. This is how 2011 was looking before the mild winter for Western Europe anyway of 2011, 2012, quite cold in this area. So you'll see that it isn't necessarily the case that you've got to have it cold around here to get a cold winter, because it's generally quite cool around here at this point in 2011, and this was a mild winter for west of Europe, was much colder, of course, for the east and the southeast Europe. This is 2010, just before the December to remember, that the winter was kicking off at this point in November 2010. It's already starting to get freezing cold. Notice again, have got evidence of the tripole, so it's pretty warm there. It's cooler just there, and then it's warmer down there. That's definitely one of the things that we do have to take into account when we have a tripole. We haven't got one for this year, but this is another year. This is interesting. This is 2009, and now notice this area is quite cold, and we certainly don't have a tripole. What we've got with this one is just generally quite cool at this point in 2009, and then warmer down here. So we like that really. So definitely no tripole signature, and 09-10 was a really cold winter, of course. This is 2008, evidence of a tripole this point in 2008. So again, it's quite warm around here, around Newfoundland. It certainly is warm, and those warm SSTs are pushing up to south of Greenland as well. Then it's cooler just here, and then it's warmer down here. So again, I think we do have evidence that a tripole is emerging at this point in November 2008, just as the cold winter, the first cold winter, the run of cold winters from 08-09 to 12-13, just as that first cold winter was beginning to get going. This is 2007. What we have here is again very warm to the south of Greenland in this area just here, then cooler around here, but not particularly warm in the tropical Atlantic either. So at this point in 07, we don't have a tripole. It's just generally cooler just there and warmer just there. Let's carry on, have a look at 2006. So again with this one, you notice how these earlier years, they tend to be very warm in the northern Atlantic Ocean. That's the warm AMO, of course, which has cooled down. We aren't out of a warm AMO yet, I don't think, but we are coming towards the end of the warm AMO. We'll be heading into the cold AMO for the 2020s, I think. So it's generally warm there, then a bit cooler there, and actually quite warm there. So at this point in 06, we wasn't all that far away from a tripole. Of course, that was a mild winter, 05-06. We go to 2005 next. We did have a bit of a tripole there, so warm, cool and warm. The winter 05-06 never really came together. Let's have a look at 2003. This is another one where it's very warm to the south of Greenland with these SSTs, then cooler there and warmer there. But again, at this point, November 23rd of November 2004, looks like we've got a bit of a tripole emerging. That was a funny winter, 04-05. It was mild in the first half, quite a lot cold in the second half. This is November 2003. So what we have there is generally quite warm just south of Greenland, otherwise coolish there, and then warmer there. So again, not all that far away from a tripole, but not quite right to have the negative NAO tripole with that one. 2002, at this point, looks like this, so quite cool in the Northern Atlantic, warmer there, definitely. That's a positive NAO type signature. 2001, that actually looks quite good for a negative NAO. So we've got warm just there, we've got it cooler there, got it warmer there. That was my very first winter forecast when I was online. So 2001, 2002, my very first winter forecast, I think it was around 22 or 23. And partly because of those sea surface temperature anomalies, I did forecast a cold winter, and it went wrong. And there are still some people that are, excuse me, that are out for my blood, actually, about the winter of 01-02 on some of the forums. So I better move along very quickly. This is how things were looking this point in November 2000. This is 25th of November 2000. Quite warm there, and then cold around here. Very, very odd looking chart. We've seen nothing like that before or since, and not sure what to make of that, but most of that is down to the very wet and stormy autumn that we had in the autumn of 2000. But that's how the Atlantic was looking just before the cool or fairly cold winter of 2000-2001. This is this point in 1999, so cool just here, a little bit warmer up there, near average around there. This is 1998, where we have a very warm looking Atlantic Ocean. So it's just generally quite warm, really, across virtually the whole of the Atlantic at this point in 1998. That's partly, of course, down to the El Nino. This looks quite good for a negative NAO. This is 1997, where we have a definite signs of a tripole. It's warm, it's cool, and it's warm. That could have been a cold winter. 97, 98 could definitely have been a cold winter if it hadn't been, cast your eyes over here, for the Super Nino of 97, 98, which ruined it. But as soon as that eased off and we got to April 1998, we saw the potential that the winter of 1997, 1998 had if we hadn't had that super El Nino event. And then this is 1996, where again quite warm in the Northern Atlantic, and then elsewhere it's just generally quite cool, so no tripole at all at this point in 1996. We go a little bit further back than that. So this is 1995. I wanted to include this in this final update because through the analogues, 95, 96 has been showing up a lot. We've seen 1995, 1996 showing up a great deal through the analogues this year. It's one of the years that has definitely been very, very close. But the one problem with it, and it is quite a big problem, is the Atlantic. Because this is how the sea surface temperature anomalies in the Atlantic looked November 1995. So we have a tripole. We have it warmer up here. Ignore that blue area just there. It shouldn't be there. That's sea ice, I think. So it's generally warmer just here. It's cooler just here. And then it's warmer down there. And we have a tripole in November 1995, before the cold winter of 95-96, which we don't have, of course, for this year. So that's going to be an important factor when we come to do the winter forecast next week, because what's going to happen with winter forecast, I'll talk more about this at the end of the video, but we will get all of the analogues together and everything else we've been looking at, and we'll try to pick out the years that are closest to this year. And I suspect that the main year we'll be picking out will be 1995, 1996. That would be the main winter, I would have thought. I don't want to prejudge anything, but I would have thought that's going to be, if it's not the main winter, it's going to be one of the main winters. So that will probably suggest a cold winter, but we do have to factor in that the Atlantic this year is not as conducive to a cold winter as it was in 1995. Let's try and get through a few more of these. So this is 1994, at this point in November 1994. We just have quite a cool Atlantic. This is all, and the years before this, actually, are all being influenced by the eruption of Mount Pinatubo, which went up in 1991. So this is 93, this is 92, this is 91, and you notice that most of these years have very cold sea surface temperature anomalies, and a lot of that is down to the effects of the eruption of Mount Pinatubo in June, I think it was, 1991. This is 1990, maybe quite close in terms of what's happening in the Atlantic. It might be quite close to this year. No tripole at this point in 1990, but we do have quite a warm Atlantic Ocean and quite warm over in the Norwegian Sea as well. This is 1989, where we see that it's cool just here, then it's warm there, and then it's near normal there. Definitely no tripole, and that's very much set up for a positive NAO. This is 1988, November 1988. Looks quite cool in the Northern Atlantic. This is 1987. So that one's warmer there, cooler there, and then near normal there. So not tremendously far away from tripole, but not quite there. This is 1986, and now we're into a cold AMO era as well, of course. So do keep in mind that the Atlantic is in a colder overall condition anyway. So it's cooler there, and then the rest of the Atlantic is just close to average, really. That's 1985, where, so what's happening there is that we're very cool just there, probably a bit warmer just there, maybe a bit warmer, sorry, down there. So actually we're doing something a bit like that, perhaps, at this point in 1985. Then we go through to 1984, so just before the very cold winter, 84-85, November 1994, looks like that. Very cold Atlantic and Pacific Oceans. Again, this is back in the era of the cold AMO, so the oceans overall are much colder. 1983 and 1982, rounded all off. Look how cold it is in November 1982 down through the tropical Atlantic Ocean. That's what a cold AMO looks like, and we are going to be heading in towards the cold AMO period when we go through into the 2020s. Just wanted to show you this. James sent this one through. I asked him if he could have a look at November 1962, because you'll know if you've been watching the updates, 62, 63 been showing up a lot through the winter updates this year. So this is a reanalysis. We haven't got satellite data, but this is a reanalysis of how sea surface temperature anomalies were looking in both the Atlantic and the Pacific, actually, in 1962, November 1962, I should say, just before the coldest winter since 1740. We find that we have got a weak La Nina signature in the eastern part of the Equatorial Pacific. Not to the extent of the La Nina signature we've got right now. Then off the coast of America, Pacific coast of America, it's fairly warmish. It's coldish around there, and then it's warm over there again. Generally, the Northern Pacific does look quite above average, and we've got this weak La Nina signature just there. In the Atlantic, in the all-important Atlantic, just before winter 62-63, in November 1962, what we've got happening is that it's warmer through here, and then it looks like it's cooler, potentially, through there. It's also quite cold down the eastern seaboard of America interestingly. So, and then it's warmer up here. This is right at the very end of the warm AMO that ran from 1940 into the 1960s, or actually it ran from the 1930s to the 1960s, I think. This is the last year of the warm AMO before it flipped to cold through the rest of the 1960s. So we're not all that far away from a tripole in November 1962, actually. It isn't quite a tripole, but I imagine as we went along, it probably did evolve into a tripole. We probably saw this area just here going quite cold. This area probably stayed quite warm. And then this warm area just here probably shifted northwards. That's a little bit speculative. But anyway, that's how the Atlantic and the Pacific Oceans were looking just before the winter of 62-63, the coldest winter since 1740, which again has been cropping up quite a lot this year through the winter updates. And sort of juxtaposed to what's happening in the oceans is the Atlantic hurricane season. So this is the 2017 Atlantic hurricane season page from Wikipedia. So just have a quick look at these. I don't think the numbers have changed at all since last week. So I think we're pretty much at the end now. We might get something in the next week or two, but let's say this is how we're ending the 2017 hurricane seasons, with 18 depressions, 17 storms, 10 hurricanes, and 6 major category 3 or above hurricanes. It has been a hyperactive season, certainly been the busiest season since 2012, and I think we have more major hurricanes than 2012 as well. A little bit of an early shutdown. It's very active through September and October. Haven't really seen all that much through November. I suppose it kind of blew itself out a little bit. But anyway, that's it. They haven't changed from last week's 11th update, and I'm not expecting much change from there. Now, I thought I'd just throw this in. Nothing has happened here, but I thought I'd just say again to re-emphasise that we are going into the easterly QBO. So these white areas on this chart from the University of Berlin, they are depicting the easterly phase of the quasi-biennial oscillation. And this is where we are right now. 2017 is this year just here. 2018 is just there. You see this white area is down to 50 HPA. So again, this is telling us that yes, we are seeing the ECQBO descending into the troposphere, and winter 2017-18 will be an ECQBO winter. It'll be our first ECQBO winter since this one 2014-2015. We've done all of the reanalysis on the QBO, so I won't go through it again, just to say that it is, and we saw it through our reanalysis, it is a potential driver for a colder winter. When the ECQBO, when we are in the phase of the ECQBO, the zonal westerlies are weakening around the northern hemisphere, and so consequently you can have a greater chance of setting up blocky ridges. It isn't as straightforward as that, and this winter, the last one that was an ECQBO, 2014-2015, tells us that very nicely, because that 2014-2015 is fairly mild winter. It's actually near normal, but so it wasn't a particularly cold winter. There wasn't much blocking from that winter either. So it's not a guarantee of anything, but it does increase your chance when you're in an ECQBO of getting a colder and more blocked winter. Of course, we will be factoring in the ECQBO when we come to do next week's winter 2017-18 forecast. If I just throw this in as well, this is Siberian snow cover. So this situation last week across Russia and Scandinavia in terms of the snow line. It was just there as of the 17th of November. If we have a look at the latest as of the 24th, well, just try and refresh the page, see if it'll refresh. So it doesn't look like it's going to. It hasn't been updated for Saturday. This is the latest anyway, and we see that snow line is now pretty much through Russia, heading in towards Europe. Most of Scandinavia has become snow covered as well. This is how things were looking in past years. So this is 2016. Virtually the whole of Russia, Scandinavia covered at this point last year. I'll run you through these very quickly. This is 2015. Again, most of Russia, Scandinavia covered, and into Europe as well. That's 2014, when the snow cover, after a really good advance for October, had pulled back quite a bit as well from Russia, also from Scandinavia as well. Not very good at all. This is 2013. Again, you notice that it isn't as far west with the snow cover as we have it right now. This is 2012. This is an interesting year because what happened in October this year was quite similar to this point in 2012. This is our last cold winter as well. So we have more snow cover across Scandinavia and Western Russia now than at this point in 2012. This is 2011, when all of Russia is covered, but we have a real deficit of snow cover across Scandinavia. And for me, if you've been watching these updates, you'll know that I'm actually more interested for us in the UK to get a cold winter. I'm more interested in what happens in Scandinavia in many ways than I am what's happening. Excuse me, again. I did a 2-hour live event with Quantum last night where I was talking non-stop. I've got this one what I'm doing tonight, so I hope you bear with me if I get a bit of a tickle in, excuse me, again, in my throat. So that's, I say, Scandinavia is one of the areas I find more important than Russia for the UK to get a colder and average winter. A real deficit at this point in 2011 in terms of snow cover. This is 2010. All of Scandinavia is snow covered. Some of that's coming down into Germany as well. Most of Russia is covered at this point. This is 2009, where we see that it's not all that far away from the current position. Actually, maybe a little bit more snow cover across Russia and Scandinavia at this point than we saw in 2009. This is 2008, when you see that virtually all of Europe, this point, is snow cover. That's quite unusual to see virtually all of Northern Europe covered in snow, and also Scandinavia. But Southern Russia doesn't have too much snow. So that's a very unusual one in 2008. That's 2007, where again the snow cover had pushed through into Europe, this time more into southern and southeastern Europe though, maybe an omen of what was going to happen in that winter of 07-08. This is 2006. At this point, 2006, most of Russia is covered with snow. Scandinavia doing quite well, not that well for southern part of Scandinavia. This is 2005. Again, most of eastern, southeastern Europe covered with snow. Western Russia doesn't have all that much snow though, so that's quite an unusual one at this point. 2005. 2004 looks like that. 2003 looks like that. I'll get through these quickly now. 2002 looks like that at this point in 2002. That's 2001. That's the year 2000, so the flooding autumn of 2000 has snow cover across northern parts of Scandinavia, but not that far into Western Russia. Quite interesting. Most of Europe is snow-free as well, just depicting the very, very strong Atlantic flow that we've got. This is 1999, very unusual events as of the 24th of November 1995, with snow cover even going into southern and southeast parts of France and northern Spain. That's a really, really unusual one to have the snow cover that far across Europe as it was at this point in 1999. Mild winter, of course, 1999-2000. This is far back as we go, 1998, when you see again most of, particularly Eastern Europe, is covered with snow. Not much in the west of Europe. That's less important in November than it is through October, so I thought I'd just throw that in for you, but it isn't as impactful what the snow cover does in November as it is through October. Sunspot activity next. So for the final time, we're going to look at the solar disk on our side of this today from solarham.net, and we do have one sunspot region. It's this sunspot region just here. Officially from Solarham, solar activity is at very low levels and expected to remain at very low levels through the next 3 days. This is for the final time for the winter updates. You'll be seeing it more beyond this, but for the final time for the winter updates, this is the GWV Weather winter update solar activity tracker. Updated to the 25th of November 2017. Our good friend James Ackroyd has been tracking this throughout the season of the winter updates. And what interesting developments we've had through these winter updates, because we started off with this large spike in sunspot numbers that we see just here, which saw these trend lines, the thick green and the thick red line, shooting up. That was through the first couple of the winter updates. But since then, we have seen a very rapid decline and descent in solar activity. So now, and this has been the case for a couple of weeks now, we are at a very, very minimal level of sunspot and solar activity. This is where we are right now in terms of our sunspot numbers. This is where we are in terms of the trend lines. We're at a really minimal level of activity. And in fact, I've got a feeling we may have entered into solar minimum. It might be a little bit early to say that. We might get one final rather large spike. I don't think we'll ever get back up to this level for solar cycle 24. The next time we're up to that level will be into solar cycle 25 probably. But we may get one final spike in solar activity, but I've got a feeling we've more or less probably gone into solar minimum now. We had a look at this last week in terms of the reanalysis and the analogues, and we know that quite crucially, this period, that's probably around 2 winters before solar minimum, has an increased chance of being a cold and a blocked winter. We saw all of that through some really fascinating reanalysis that we looked at last week. But certainly from a solar level, or from a solar perspective, we are very much at a minimum level of activity. And then the last thing I wanted to look at for this final update is November. We've been trying to get together some sort of November pattern matches. Of course, we're not through November yet, so this is how the 500 millibar height anomaly for November 2017 is shaping up to the 23rd of November. And what we see is that it's a very unusual pattern. So we've got a ridge out to our west-southwest in the Atlantic. We've also got a trough that's between Greenland and Iceland. But we also have a blocking feature around here up towards the North Pole. And James has been having a look back through the reanalysis and go right back into the 1800s and has really, really struggled to find a year that comes close to this. And from a reanalysis perspective, again, we can't really look at temperature and precipitation either, because no great deviations have happened there either. I think we're going to finish up very close to average with the overall temperature. I think we're probably going to finish up quite close to average with precipitation. East areas will probably have quite a dryish November, but west areas will probably have quite a wettish November. And this is all proving to be a real headache in trying to find some reanalysis for November. So when we're going to do the winter forecast next week, I don't think November is going to be much help at all in trying to look back at past years that had similar patterns in November and then going forwards to create a forecast, because this November is looking very, very unique. What we have done is explored some reanalysis for the Novembers before the winters that have been cropping up a lot within the analogues that we've been looking at this year. So this, for example, is November 1887, and the winter of 1887-1888 has been cropping up quite a lot in our reanalysis. So this is how November 1887 looked, with blocking out to the northwest and below average heights to the north, to the east and the southeast, I should say, and the jet stream is going like that. So that's preceding the cold winter of 1887-1888, of course, which has that sort of pattern in terms of the overall flow and setup. That was a cold winter. But do bear in mind, none of these charts that you're going to see for the Novembers preceding the winters that have been cropping up a lot in our winter updates, none of them are going to be particularly close to the November pattern that we've got this year. This is 1911, November 1911, before the winter of 1911-1912, which again is another year that's been cropping up quite a lot this year. That looks like that very stormy November, very wet and zonal. That's how the winter of 1911-1912 looks from a reanalysis perspective. Very wet, very unsettled. This is November 1933, so this looks like it's quite a cold and block month with high pressure to our north and low pressure to our south, and probably bringing in quite a lot of easterly winds. And that's how the winter of, so we're not going through, so something has gone a little bit wrong. I took the, that's right. Okay, so sorry about that again. It really has been a very long few weeks. This is how the winter of 34-35 looks, which I think is probably the wrong winter, but it looked like that, very wet and unsettled. Let's carry on. We go through to November 1954, and November 1954 is a mild and zonal month, doing something like that with a flow of jet stream, high pressure out to the east and the northeast. The winter of 1955 was a cold winter, has low pressure to the south, low pressure to the east, and high pressure close to Greenland. We move on. This is November 1962. I said earlier that 62, 63 has been cropping up a lot within our analogues packages this year. The November of 1962 looked like that, already setting up the cold and block pattern. So we have quite a lot of high pressure in the Atlantic, quite a lot of high pressure over towards Western Russia, low pressure to our south, already pulling in quite a lot of cold easterly and northerly winds in November 1962, before we go into this pattern for winter 62-63, which has all of this high pressure to the north and low pressure to the south. And again, we do something like that with the wind direction. November 1968, before the winter of 68-69, which again, it's another winter, been cropping up a lot in our analogues. That one has lots of high pressure to the north, to the northeast. Low pressure is down to the south. So again, we're already, you'll notice many of the colder winters are already starting to set up the cold pattern by November. So that's something that's quite interesting, and it's always something that I've thought that November doesn't have to be very cold in its own terms, but in terms of the broad synoptic northern hemisphere pattern, you do want to be seeing signs that it's starting to set up something a little bit colder. Many of these cold winters are already beginning to get the building blocks in place through November for a colder winter. That's how winter 68-69 looks. Was a cold winter, low pressure to the south, high pressure to the north, particularly focused around Greenland, and it became very cold in February 1969. A long run then to November 1995. So again, here we go, we've got 95, 96 appearing. This is how November 1995 looked. Again, we see a bit of a blocking signal to the south of Iceland, with low pressure in the east of Europe, and we pull in the flow rather like that. Actually, November 1995 was quite a mild month. It wasn't a particularly cold month. There are a few colder stats, but it wasn't remembered as a particularly cold month. But you'll see from a broad 500 millibar height anomaly perspective, the building blocks, even though we was on the mild side of the blocking, and actually what we was doing in November 1995 was, with low pressure there and a ridge extending down there, was actually pulling up more in way of southerly winds. But that doesn't matter. It doesn't matter if it's a mild month. What matters is that from a broad anomaly perspective, in terms of the pressure and the heights, we are setting up the building blocks for the cold winter of 95-96, which looks like that. Next week, we're going to put everything that we've looked at through these analogues together, and we'll come out with the best match. And I've got a feeling, I don't want to prejudge anything, but I've got a feeling 95, 96 will probably be the best match out of all of the years that we've looked at in terms of the analogues. But we will know next week which winter is favoured in terms of the reanalysis. This is November 1996, so winter of 96-97 has been appearing quite a lot. So this one has low pressure to our east, high pressure to our west, quite a cold month in November 1996. That's how the reanalysis 96-97 looks. We spoke about this before, it's been cropping up a lot, so it's a bit deceptive, this reanalysis, because it's a front-loaded winter, it's cold in December, early January 97, and then it gets very mild for February 1997. This is November 1999, and you'll notice this one just has a ridge through the UK and into Europe with low pressure to the north. This is preceding the mild winter of 99-2000, and you'll notice that generally the jet stream is to our north. It just looks like quite a quiet, benign sort of pattern. Actually, winter of 99-2000 became quite unsettled, but we haven't got the building blocks there to suggest we're going to go on and have a cold winter, and we didn't have a cold winter through 99 and into 2000. This is an interesting one. This is how things were looking in the winter of 99-2000. So what we see with this one, that's got a little bit wrong, so what we see with the winter of 99-2000 is that we've got a strong zonal signal. So all that happens is that the high pressure we had in November, the above average heights, they're pushed away to the south and to the west, and we just have all this low pressure up to the north and a strong zonal flow coming through. So it does appear that November's broad pattern, doesn't matter what the temperatures are doing particularly, it can either be mild or cold, but it does seem that the broad pattern that you get in November in terms of what's happening across the northern hemisphere is quite important for the remainder, or for the coming winter, if you like. This is 2000, November 2000, very, very wet month, of course, very stormy with this trough almost centred over the top of the UK. But look what's happening up here, above average heights through Greenland, and also down to the north of Scandinavia. And that's one of the reasons it was such a wet autumn, actually, because this trough, instead of being up around Greenland and Iceland, was actually centering over the northwest of Europe. And that's the reason it was so phenomenally wet through the autumn of 2000. But you see that the building blocks again through November 2000, they are there to our north. That's how winter of 2000-2001 looks, with that blocking signal continuing. Almost a very, very cold winter, 2000-2001. Just didn't quite come off of the south, but for the north, there was some really quite cold weather. This is November 2001. So winter 2001-2002, been cropping up quite a lot. This one's just a zonal signal, so high pressure to our west, low pressure to the north, do something like that from the jet stream. 2001-2002 eventually became a mild winter, quite an odd looking pattern with high pressure to our south, dragging up the flow like that, but it wasn't particularly cold in that winter. This is November 2007. Again, you'll notice the ridge is out to our west. We'll do something like that with the flow and with the jet stream in the winter of November 2007. That's how 2007-2008 winter looks. High pressure to the south again, low pressure to the northwest, and we pull in the winds from the west-southwesterly direction. Do keep in mind, none of these analogues are coming out close to the analogue that we've got for November 2017. This is November 2010, already setting up the December to remember, of course. We've got the blocking around Greenland, we've got low pressure through west of Europe. That's what jet stream's doing. And that, of course, continues into the winter. That is how reanalysis winter of 2010-2011 looks. Is a strong blocking signal. We know it's a front-loaded winter, though. Got mild, even very mild, by February after the December to remember. This is November 2011. So this one has low pressure to the west, high pressure just to the east, and low pressure over there. And we're doing something like that with the flow and with the jet stream. Rather a bizarre looking setup in November 2011. Wasn't a particularly cold winter for winter of 11-12. That's how it looks with high pressure out to the west, doing something like that with the flow. And then we go through to November 2012. I think this is our last one that's been cropping up a lot, the winter of 2012, 2013. So this is how November 2012 looks, with low pressure below average heights just to the west of us. Bit of a ridge over in the southeast of Europe. And this was quite interesting because there's no real sign here that we are going to go on and have a cold winter, because we've already said that you want to see the building blocks in place. In terms of what's happening in the Arctic, there is a little bit of above average heights up there in the Arctic, but not really to any great extent. So you wouldn't particularly look at that and think we're going to go on and have a cold winter. But keep in mind that with the winter 2012-2013, it didn't get cold until later, and the real cold was actually unleashed in the spring of 2013, in March 2013. But that's an interesting one, because it's a bit different in that it is preceding, that November is preceding a cold winter, and you wouldn't particularly look at that and think that you're going to have a cold winter following. That's how winter of 2012-2013 actually looks from a reanalysis. We do have a strong blocking signal. That was very much down, I think, to the southern stratospheric warming that occurred through January, early January 2013, had that tremendous southern stratospheric warming. Now, again, coming back to November 2017, so none of the patterns that we've seen for November 2017, again, this is a recap of the pattern that we've got so far for November 2017, have come close to what we've got this year. So we've got the high pressure out to the southwest, we've got low pressure to the north, and we do have a bit of a blocking signal. Now, this is to the 23rd of November. And what I think might happen is that in the final days of November, we might see this blocking signature strengthen a little bit. If it does, that's going to be a fairly good omen, I think, for a cold winter, because we've already established that November very often develops the building blocks for a cold winter. We've not got enough there yet to suggest that we're going to have a cold winter following. But if in the closing days, and I probably will show you this at the very start of the winter forecast, just to pick up where we're leaving off, if this blocking signature over the pole is strengthened by the time you get through to the end of November, that could be quite interesting. We have managed to find 1 year, just 1 year, that possibly is quite close. Isn't an exact match, it's possibly quite close, and that's 1950. So again, it does have a bit of a weak blocking signature up there. Has some above average heights, then more over towards the central Atlantic though, so it's not a perfect match by any means. And then this trough over the UK is deeper in November 1950. So what do we think? Again, this is 2017. This is 1950 in November 2017 there. November 1950 just there. What do we think? Is that a match? Isn't it a match? I'm not sure. It's perhaps in some ways close. But I don't think we can say even that is particularly a match. This is how 1950, 1951 came out. So it had a very cold December in 1950 with low pressure over, a trough of low pressure over to the south of the UK, and then it had this strong ridge through the Atlantic going up to Greenland, in some ways similar to the December to remember of 2010, and also in some ways similar to December 1981, a little bit toned down compared to those 2 months, but it was a pretty cold December in 1950, and then quite a front-loaded winter. So January 1951 goes milder. It does have some cold stats, but overall it's a more Atlantic-driven month in January 1951. And this is February 1951. Again, very unsettled signal and not overly cold either in February 1951. I think got cold again in March, though. This is how the winter overall of 50-51 looks, with low pressure around there, high pressure just there and high pressure over there. So we do something like that for the jet stream. Front-loaded winter, cold in December, and then less cold and eventually milder through the remainder of the winter. But coming back to that reanalysis chart for 2017, it is quite interesting that November 2017 has got a bit of a blocking signature to the north, but it's quite weak. Otherwise, not a huge amount going on. It is a very unusual month. As I say, we really have struggled. James particularly has been working night and day on this to try and find a situation that's similar from a 500 millibar height perspective to November 2017. And we did come up with 950, but it's not really a particularly good match, I don't think. And I think we're probably going to, in the end, have to say that December 2017 is going to be a very unique and one-off month with no real reanalysis to go on for it. But if that blocking signature is strengthened to our north, it might be a sign that building plots are getting in place for a colder winter. And that, of course, will be revealed next week. So this final winter update has reached an hour. It's been the longest one so far. Had a huge amount to cram in again. But that's it. We've come to the end of the winter updates. So I hope you found them interesting and informative. They've been the most extensive and the most exhaustive and in many ways the most tiring winter updates that I've done since I've been doing these updates, first ones for winter 2012-2013. Certainly I think they're the best we've ever done, but I hope I'll leave it to everybody else to judge really whether they've enjoyed these winter updates that we've done this year or not. But whether you did enjoy them or not, that's it. We're at the end of them. So next week, just 1 week today, same time, same place, we will be releasing the GWV.com 2017-2018 forecast. And there's not much else left to say, really. So I'm going to sign off now and say, come back next week when all will be revealed. This afternoon, we've got Terry Scoley's winter forecast, though, on Terry's page. But we'll have a bit of a Chris update tonight. But before my voice completely gives way, I'm going to say at 1 minute, at 1 hour, 1 minute, thanks for watching and come back next week for the winter 2017-18 forecast.